Unit 10 Chemistry. Halohalkanes and haloarenes. The replacement of hydrogen atoms in an hydrocarbon. First we learn about hydrocarbon. X. Actually hydrocarbon is made by this is the compound which is composed by hydrogen and carbon only. Yes, this is a methane. It is composed of hydrogen and carbon, hydrogen and carbon, hydrogen and carbon, hydrogen and carbon. There is no other there is no oxygen is there, and there is no any nitrogen is there, or nitrogen oxide is there. Yes, in the functional group we can come across this point, that is nitrogen oxide, and alcohol, that is OH. But if we consider CO2, is this a hydrocarbon? No, it is not an hydrocarbon. Okay, I think you are understand. H2O, it is composed of hydrogen. Can we call it as an hydrocarbon? No, there is no carbon in this, so it is not an hydrocarbon. So the hydrocarbon is a compound which is composed by carbon and hydrogen, then it is called as hydrocarbon. Okay, I think it is clear with you. Next is aliphatic or aromatic. Aromatic is a compound which is like a cyclic compound. Benzene is the best example for it. There are three rules are there, you can refer in the first PU. One of the major rule is Acker's rule, and it is an it actually produces smell which is like a scent, so it is called as aromatic. We come across only benzene only, so aromatic we remember this only as the aromatic. Aliphatic, like this, if I consider penton, this is also an aliphatic. Okay, I think you are clear with this. Okay, here what is the definition? The replacement of hydrogen atom in a hydrocarbon aliphatic aromatic by a halogen atom results in the formation of alkyl halide. Yes, this is the main sentence we come across to the title of the chapter, that is halohalkanes and haloarenes. Yes, if we consider ethane, is this hydrocarbon? Yes, it is of course hydrocarbon. If this is an hydrocarbon, here replacement of hydrogen, you can replace any of the hydrogen. Okay, I like to replace this hydrogen. If this hydrogen is replaced by any of the halogen, what is the halogen? 17th group of the periodic table, that is fluorine, chlorine, bromine, iodine. These are the major halogens which replaces the hydrogen in the hydrocarbon or either aliphatic or aromatic. Example, take this. Yes, this is a benzene. Actually there are 6 hydrogens are attached to this. If any one of the hydrogen is replaced in aliphatic or aromatic by this halogen, then also we can call them as respectively alkyl halide and aryl halide. First, like the if we consider hydrocarbon, then it is called as alkyl halide. If we consider aromatic or aliphatic, then we replace hydrogen, then it is called as aryl halide, that is in other name is called as haloharine respectively. Okay, I think you are understood with this. Haloalkanes contain halogen atom attached to the sp3 hybridized carbon atom of an alkyl group, whereas haloarenes contain halogen atom attached to sp2 hybridized carbon atom. X, we can observe. Okay, that is called as methane, ethane, propane. There are 3 number of carbons are there, so we can call it as propene. Let us consider propane. If we consider propane, if you want this to be what we call halohalkane, one of the hydrogen is replaced by halogen. Okay, this halogen is replaced this hydrogen is replaced by halogen. Yes, this halogen is attached to the sp3 hybridized carbon atom. Look at this, this is attached to this carbon. What is the structure hybridization of this carbon? Let's look at this. There is sigma bond, sigma bond, sigma bond, sigma bond. and also we can say that there are four single bonds are there, so it is actually sp3 hybridized carbon. In this we can they are concluded generally that all halohalkanes are halohalkanes are sp3 hybridized carbon atom. Okay, next, aryl halide. In aryl halide, consider benzene. Okay, here hydrogen is replaced by halogen. What is this halogen is attached to this carbon? Is this carbon sp3 hybridized? No, it is not sp3 hybridized. It is sp2 because there is a double bond where carbon is attached to the carbon with double bond. So we can conclude that aliphatic aromatic compounds are sp2 hybridized haloarenes, but haloalkanes are sp3 hybridized carbon atom. Okay, let's jump into the next concept, sp2 hybrids. Many halogen containing organic compounds occur in nature, and some of these are clinically useful. Yes, so these haloalkanes and haloarenes are occur in nature also. These are very useful in industries and also in day-to-day life. Okay, they are used as a solvents, relatively non-polar compound. Yes, these haloalkanes are used as a solvents like water. These haloalkanes are used as a solvents for non-polar molecules, non-polar compounds. Some of the polar compounds dissolve in water, but some of the non-polar compounds does not dissolve in water. This non-polar component can be dissolved like this in haloalkanes. So it is very useful in the solution, making of solution of non-polar compounds. Okay, and as starting materials for the synthesis of wide range of organic compounds: chlorine containing antibiotic chloramphenicol. Chloramphenicol, yes, this is the major product. Chlorine, it contains chloro. In the name also we can conclude that chloramphenicol, produced by the soil microorganism, is very effective for the treatment of typhoid fever. Yes, this typhoid is caused by mosquito is the agent for this, but really virus is the injected virus is injected to humans. This causes the typhoid fever. Okay, typhoid fever is caused. Yes, is there any medical for this? Yes, there is a medicine. But how can it be prepared? Yes, this is prepared by halohalkanes. That's why it is very useful. That treatment that is called as a chloramphenicol. Okay. Next, our body produces iodine containing hormone. You already learned about in 10th and 11th also, thyroxine hormone which produces iodine. The deficiency of which causes a goiter. Yes, the deficiency of which causes a goiter. If this is the neck, it swollen like this. That is called as a goiter, which is caused due to the deficiency of iodine due to the less secretion of thyroxine hormone. Okay, did you understand? Yes, less secretion of thyroxine. For this there is a treatment that is made by the haloalkanes. Here also we can come across the useful method of haloalkanes. What we call for that thyroxine, the deficiency of which causes a disease called goiter. Synthetic halogen, in this also halogen helpful. Synthetic halogen compounds, that is chloroquine, used for the treatment of malaria. This is also one of the important. Chloroquine used for the treatment of malaria. Malaria and typhoid are caused by a virus, but the agent is mosquito. You already know about that. Yes, chloroquine. This chloroquine is used as a treatment of malaria. Okay. Allothane is used as a anesthetic during surgery. Yes, sir, you already learned about anesthetic during surgery, because in unconscious state we cannot the receptor will be at sleep, and we cannot feel the sense of the pain that when you cut the stomach or any other parts of the human, we cannot feel that. So anesthetic is given. What is that anesthetic made up of? Anesthetic is made by haloalkanes. That name is called as halothane. Okay, 1 minute. Sorry for the inconvenience, guys. Let us start again the class. Yes, let's start it. Okay, what allothene is used for anesthetic during surgery? Certainly, fully fluorinated compounds are being considered as a potential blood substituent in surgery. In surgery, there is a fluorinated compounds like it means a fluorine halohalkanes. It means fluorine attached to the any of the haloalkanes. It is represented by R. You already know about that in organic chemistry. That is in the first PU. So F is attached to haloalkane. This is useful in the compounds of being considered the potential blood substituent in surgery. Okay, in this understood it. Until there you have understood about that. In this unit we will study about the important methods of preparation, physical and chemical properties and uses of organohalogen compounds. Yes, in this chapter we are going to learn about the synthesis of these haloalkanes and the methods of preparation, physical and chemical properties of these, what are the useful and advantages and disadvantages, and also organohalogen compounds. Okay, let's jump into the chapter. 10.1 classification. The main thing is classification of haloalkanes. It is such a large number of haloalkanes we can find across in nature and also under the scientists are synthesizing. So there is a need for classification. Okay, first on the basis of number of halogen atoms. Yes, if the number of halogen atoms is 1, 2, on this basis maybe they classified. Let's read and jump into this. This may be classified as, okay, this may be classified as mono, di, polyhalogen. Yes, polyhalogen belongs to more than 2. For 3 we call it as di, for 4 it is called as tetra, and etc. There for you further reading, Google it. Compounds depending on whether they contain 1 or 2 or more halogen atoms in the structure. Yes, we can take the example for this. Let us take according to example, there is ethane is taken. Yes, in this ethane how many halogens you find? Yes, one alkane, one haloalkane. In this we already know mono. What you call for one haloalkane? Mono. We can use the scientific words, so it is called as monohaloalkane. Oh, in this how many halogens you found? 2 halogens. Yes, that's why what is the name for di? Sorry, 2, that is dihaloalkane. In these 3 it is also called as polyhalohalkane, but there is specific word for 3, that is called as tri. That's why we are using trihaloalkane. Okay, we can studying both haloalkane and haloarenes simultaneously, so we have to discuss about haloarenes examples also. Okay, yes, actually I told that the benzene is the only aliphatic or aromatic compound we use most, so I didn't explain about that. Okay, let's benzene is the one of the most important aromatic, so we can learn from that only. In this aromatic, how many haloalkanes found? 1. In this 2. The same thing happens, mono for 1, di for 2, tri for 3, and the remaining thing name does not change, haloarene. It changes only when the carbon number changes or any halogens mainly halogen changes, that is if it is attached to fluorine, chlorine, bromine, any other thing. Okay, you don't think about that. Let's concentrate on the number of number of halogens attached. Monohalo compounds may further be classified according to the hybridization of the carbon atom to which halogen is bonded, as discussed above. Actually, we have discussed about the monohalo compounds may further be classified according to the hybridization of carbon atom to which the halogen is bonded. Yes, that is actually haloalkanes are attached to sp3 hybridized, but in haloarenes it is attached, in haloarenes it is attached to the sp2 hybridized carbon. Yes, this is already discussed. In that basis also we can classify. Okay, compounds containing sp3 carbon bond. Okay, here already told that in the previous also told that alkynes are bonded to sp3 hybridized carbon. Alkyl halides, haloalkanes There are two names which you have to remember: alkyl halides or haloalkanes. In alkyl halides, the halogen atom is bonded to an alkyl group. That is, halogen atom bonded to alkyl group. They form homogeneous and series represented by CnH2n. Actually, you know about the homogeneous series for CnH2n plus 2 for haloalkanes. For what we call alkane compound. But here what happens, 2n plus 2 for alkanes compound, but here X is replaced on nitrogen, right? So in nitrogen we have to minus 1, so 2n plus 2 minus 1 is equal to 2n plus 1. Okay, that's why the homogeneous is represented by homogeneous series. Homologous series is represented by CnH2n plus 1x. They are further be classified as a primary, secondary, tertiary according to the nature of carbon in which halogen is attached. Yes, here halogen is attached to carbon. Okay, we most thing is first find the halogen in all this, then choose the carbon which is attached. Yes, we have to focus on these carbon to classify. If this carbon is attached to only one carbon, okay, only one carbon, then it is called as primary or 1 degree haloalkane. In this, concentrate on this. Here two carbons are attached to this carbon, that means it is called as secondary or 2 degree. Next, here this carbon is attached to 3 carbon atom, so this is called as tertiary. Okay, are you clear with this? Primary for one carbon attached to the sp3 hybridized carbon. Secondary for 2 carbons attached to sp3 hybridized carbon. Tertiary for 3 carbon attached to sp3 hybridized carbon. Okay, clear with this? Main thing we have to focus here is homologous series and this classification. Okay, let's move on. Halohalkanes. These are the compounds in which the halogen atom is bonded to an sp3 hybridized carbon atom next to two carbon-carbon double bond. Okay, sorry for the disturbance. I will continue from halohalkanes. Yes, what are halohalkanes? These are the compounds in which halogen atom is bonded to an sp3 hybridized carbon atom. Yes, here till here we know that. Next to two carbon-carbon double bond. This is the only thing. Other than that, we can tell the definition with what we learn in the introduction. What we learn: halogen atom attached to the bonded to an sp3 hybridized carbon, but these carbon this carbon is attached to the carbon which is actually sp2 hybridized. That is what they are given as next to carbon-carbon double bond to an alkyl carbon, allylic carbon. We know that we call this as allylic carbon, so you can say that this is an allylic halide. Okay, yes, when halogen is attached to the sp3 hybridized carbon, but that carbon is attached to the double bonded carbon, then this is called as allylic halide. Okay, allylic halide. Next we come across benzylic halide. Okay, benzylic halide. These are the compounds in which the halogen atom is bonded to an sp3 hybridized carbon next to aromatic ring. Yes. Yes, you can see that. This is the example. Here halogen atom is attached to the sp3 hybridized carbon next to aromatic ring. It means halogen is attached to this sp3 hybridized carbon, but this carbon is attached to the aromatic ring. Then it is called as a benzylic halide. We can learn. We can here. It is a. We can also classify this as primary benzylic halide, and here we can classify it as secondary and tertiary. Okay, we already know about that. Here also halogen is attached to the carbon, but this carbon is attached to the aromatic ring. That's why we can call it as benzylic halide. Okay.